All right, so this is the remainder of our calculus notes. Hopefully you guys are going to be able to see this all right. You'll just need to finish this up, and this is all you have to finish. So at the top of these notes, I don't have room to write it, but you guys should have room at the top of your notes above the word symmetry. Write this down, okay? There's such thing as what's called an even function and an odd function. So an even function, there's two things to know, okay? One is if you would plug in f of negative x, that's going to equal the function if you plugged in positive x. So kind of like if you plug in -3, you're going to get the same answer as if you plug in +3. That means it's called an even function. And what will also happen in an even function is the graph is going to be symmetric over the y-axis. Okay, so we're going to jump right now. We're going to do this one in a second, but this is an example of an even function. So we're going to jump to this. So this is an absolute value +1. So the first thing I'd like you guys to do is just sketch the graph. Kind of like the point of the V is going to be up 1. Okay, and then you're going to just go up 1 over 1. So this is like a V-shaped absolute value graph. So let's kind of notice that this is true. It's definitely easy to see that it's symmetric over the y-axis, so it's even. But then let's kind of just plug in some numbers here. Let's plug in -2 and see if that's equal to 2. And I'm just gonna change to orange here. So f of -2, so if you go back 2, or if you plug a -2 into the function, that will turn to +2 plus 1, that's equal to 3. And if you plug in a +2, that's also equal to 3, okay? And then maybe we could put in the symmetry line and write symmetric, oh my gosh, my pen's having problems. Symmetric over the y-axis, okay? So there is an example of an even function. Let's talk about this function, the first one. It's not even and it's not odd. We're gonna learn what an odd function is. It's neither. Okay, but there is symmetry involved, and that's, you know, this is talking about symmetry. This was just some extra information in the book that I'd like you guys to have written in your notes. So this is like a parabola, it's just flipped sideways. So if you know what y equals x squared looks like this, well, x equals y squared, it's gonna have 0, 0, and then it's gonna be a parabola this way. So it is not an odd function, it's not an even function. The only thing we could say here is that it's symmetric over the x-axis. So we're kind of talking about symmetry here, but let's just say it's, one, it's not a function at all, so therefore it can't be an odd or even function, okay? And it is not odd or even. That's kind of implied because it's not a function. Okay. Next thing we're going to talk about is this one down here. I don't have a lot of room, but I'll maybe show my work right here. This is an example of what's called an odd function. So again, what I did on my notes is I kind of wrote this just up here at the top. Even function and odd function. So an odd function is if you plug in a negative here, like if you plug in a -3, what's going to happen is you're going to get the negative answer if you would have plugged in +3. So if you plug in -3, let's say you get 7, you would have -7 when you plug in a +3. It's like completely opposite. It's a really odd thing, right? So this graph is symmetric over the origin, like a spin. So if you think of what -2x to the third looks like, you can graph it in Desmos if you want. I'm going to graph it right here. So you guys know a cubic function usually starts low and then it flips right at the origin. Well, since this is negative, it's going to be kind of steep and it's going to flip at the origin. Okay? So this, there's the origin. There you go. This is symmetric across, like if you would rotate it 180 degrees, it's symmetric. So it's symmetric over the origin. And then let's try plugging this in. Okay, how about we plug in -1 and +1? So at -1, if you plug a -1 in right here, well, -1 cubed is -1 times 2. So this is up 2, and +1 is down 2. So I'm going to write right here, f, let's test to see if f of -1 equals negative f of 1. So I'm just doing this as an example. So f of -1 is 2, and is that equal to negative? When you plug in a +1, you get -2. And yes, that's true. So that's an example of an odd function. The next 2 examples I'm going to go over very quick. The fourth example is not symmetric at all. It is a power function 3 to the x. I don't know why this isn't letting me switch pages. Here we go. It's thinking. Here we go. All right, so let's just go ahead and talk about the graph of this. It's going to have a limit of 0, and then it's going to shoot up high. Okay? So actually, this is an exponential function, not a power function. It's an exponential function. It's not symmetric. It's not odd. It's not even. So you would just say not symmetric over anything. There's nothing about odds or evens. That was the hardest thing probably of these notes. And then finally, this is a circle. You can graph it on Desmos. It's a circle with radius 2. So let's think of what's true about the symmetry here. Is it symmetric over the y-axis? Yes. Is it symmetric over the origin? Yes. So this is an example of an odd and an even function because it's symmetric over the x-axis and the y-axis. And we're not going to plug in the numbers. Okay, this we are saving for in class on Monday. Okay, so all you have to do at Show Me Monday is just this last page of notes. All right, 7 minutes. Sorry, it wasn't under 5, but there we go.